Okay, we're going to be doing the last of the transformations that we're going to be doing this year, and this is going to be dilations. We've actually kind of already done dilations. They are a scale factor, and so we are going to be using the variable k again. So that k factor, and remember a k factor is always a multiplication, which we'll talk about here in a minute. But a reflection is a flip over a line of reflection. A translation is a slide. And a dilation is a change in size. So think about if you've ever been to the eye doctor and they put drops in your eyes and it dilates your eyes, it changes the size of your pupils. So a dilation is a change in size. So the things to know about dilations is the pre-image and the image are similar figures. So what that means is that they don't change shape, they just change size. And each side length changes in the same ratio or the same k factor as all the other ones. And if your k factor or scale factor is greater than 1, the image will increase in size. And if the scale factor is less than 1, then it will decrease in size. So less than 1 would be a fraction. So let's just look at this one. Here we have a k factor of 3. And so what that means is we're going to dilate this triangle ABC using the scale factor of 3. And since k is a whole number, it is going to increase in size. So it's actually going to get 3 times larger. And here's that scale factor is always a multiplication problem. So we're just going to take each of these points and multiply the x value and the y value by 3. So if I look at this first one, I have -1, and I multiply it by 3. My new x is -3. So then I have a 1, multiply it by 3, and it's 3. So if I come up here and I go -3, I'll do it in a different color. I'll do it in blue. If I go -3, +3, here's my new a. You can see it's stretching it out. So then let's look at this b. We have -3. I'm going to multiply it by 3, so that means this new one is a 9. And if I have 2 and I multiply it by 3, it's a 6. So let's come up here to b. I'm going to do 9, and here's 6. So here's my b. And then my c, I have a 1 times 3 is 3. -2 times 3 is -6. So I'm going to come over here to 3, and there's my 6. So I'm going to come down like this, up to the b, and you can see it got considerably larger, 3 times larger. So here's one where the dilation or the k factor is a fraction, which means that it will actually decrease in size. And remember, your scale factor is always a multiplication problem. So let's just come down here. We'll do it in blue again. So you can see I had a -6, 6. So I cut them both in half. And so I have a -3, 3. So if I take 4 and cut it in half, I have a 2. If I take 6 and cut it in half, I have a 3. If I take -6 and cut it in half, I have a -3. Don't ignore your negatives. And -4, cut it in half, I have a -2. So let's just go ahead and plot these. So I have -3, 1, 2, 3, +3. Here's my s. And then I have 2, 3. Here's my t, and then I have -3, -2. It appears to have moved a little bit, but that's really only because it is straddling the vertices or the axes, and so it does appear to shift a little bit, but it really hasn't. It's just a change in size. So let's come down here. Now we need to find the scale factor. So now we're trying to find our k factor. So if all I have to do is look at these, it went from -2 to -6, and both the x and y will always be multiplied by the same number. and then it went from 3 to 9. So obviously my K factor is a 3.